Hey Nick, so I got this set up here with everything wired up. This is AC1, my input. This is AC1 too. This is my output, and I've got the VCC and the ground connecting here. I've got this whole setup here with my voltage set to 7 volts, my current set to 50 milliamps. And just so you know, just to get this out of the way, my PLL does not work phase lock properly, okay? It does do something though, and I want to show you because I do not think that I'll be able to get it to lock properly. There is just no way it's happening. I spent 2 weeks at this already. I've changed my components a bunch of times and nothing is happening. So we start at 100 kilohertz. This is not the locking frequency whatsoever, okay? This is the minimum I want to show you at. There are several frequency ranges that I found where this locks the best. So we started at 100K, and we're interested in mostly double-digit megahertz ranges, okay? So let's go up. 200K, 300, etc., right? So it goes. You can see like the messy FFT, which is connected to the source of my PLL, forming spikes, as it should, right? As should be expected. Those are my like mini baby phase locks, okay? So we go up in frequency, go up, and here's where it starts getting better. So yes, at minimum frequency, my output looks kind of mid compared to what it's supposed to look like. Just so you know, for reference, the yellow line is my actual output, and my blue line is my output the way it's supposed to be, as it's wired up through this direct connection to the oscilloscope. Not the oscilloscope, but the function generator. We go back up in frequency, and as you can see, the lines of, first of all, you know, the phase locks continue, and second of all, the slopes of the lines are starting to slowly match each other. So we are approaching 32 megahertz, and at 32 megahertz, I found it to look the best. That's like the minimum value at which it looks the best. So this is 32 megahertz. It's already starting to form together. It looks pretty good. Let's continue going up. The second most value I found it to look well at is, I think, 48 megahertz. We'll find out here in a second. So let's go up to 48 megahertz. Okay, that doesn't look terrible. Not as good as it used to be. Something must have happened. Let's just keep going up, because the next value is 63 megahertz, or 62 or 61, you know, in that range. Oh, look at that. It's starting to look better. The output wave is starting to match the expected output. It's starting to look good. There you go. See, that's good. That's good. But again, there is no proper phase locking going on here, at least not as far as I can tell. Something may be wrong. Maybe my voltages are wrong. Maybe my currents are wrong. Maybe I'm suffocating my power distribution. Anything is possible, but I just cannot point my finger to it. But I am getting an output, and it's a functional output. I think it makes sense. It's just not perfect, and it might be a far cry from what's expected. I do not know. I cannot tell. Me and Max and Eric and David and a few other people spent the past weeks working on this, and none of us got the hours to work. I'm not trying to throw shade at those guys. I'm just saying that, you know, the 5 of us could not figure it out, and the one of me definitely cannot as well, okay? So here, we went to 100 megahertz. I can keep going up all the way to 260, but you're just going to see more of the same. Let's just continue going up. Mini phase locks, you know, keep locking with each other. The slopes don't really change at this point. It kind of, you know, at higher frequencies, it obviously performs better than at low frequencies, which is expected. Whatever. Okay, this looks good to me. It does not look terrible. I am happy with my results. I don't know if you are, if this is satisfactory. I am going to use these results, this data, to put together my lab report, and I'm going to provide some feedback of things that, you know, students next year taking ECE 323 can take care of before they start building their PLL, once they have a fully functioning diode ring mixer. Oh, you see that? We are at 144 megahertz right now, and the pattern is starting to break. So let's just keep going up. Let's see what happens when we get all the way to 260. This is going to take some time. But yeah, I highly recommend you read through my report. I'm going to take the next few days writing it out. I may do a little bit more testing. I may interchange my components a few more times, but I do not know what I can do to make this better. This is not good, not terrible, literally, okay? And also I have a bunch of things to take care of. I already was kind of busy this week with proctoring my exam sessions and saying goodbye to Duncan. And now I have the capstone session coming up on Friday, and I have to get ready for that. It's in 2 days. So I hope this video is satisfactory. Look, this is not terrible whatsoever. Again, this might be just noise, insertion loss that I am playing with here. It can be anything, okay? But I will take this as a pass that my circuit is working. And just, we're almost at 260 right now. We're at 225 megahertz. Just keep going, 30 more megahertz. Playing around here. I'm not gonna bother to show you the output of the blue wave, or the FFT for the blue wave, because it looks pretty much the same. It's just a little bit ahead phase wise, just a few degrees ahead, but it mostly exhibits the same behavior, which the expected output matching the actual output is a good sign, right? So we're at 240 megahertz, not 260 like I thought. There you go. And here's another thing. My VPP is set to 2.7 VPP, right? That's my amplitude. At lower voltages, it just didn't work properly. I could set it to 3.5, but that's a little bit too high, and it didn't really improve results that much. Let's see what happens just for fun. So amplitude level 2.77. I will increase it to 3 and see what happens. 3 VPP. Boom, 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 right? All it did was just decrease the amplitude of the output wave. It decreases the amplitudes of both, but it decreases the amplitude of the actual output compared to the predicted one at a greater degree. And let's go back to 2.7. This is my VPP and ground. My VPP, not VPP, but VCC, right, is set to 7 volts as opposed to 5 volts. But there is some strangling going on here with this 50 milliamps failing to bring the 6 volts up to 7 as it should be. So it just gets stuck at 6 volts, 5.97, and fluctuates up and down. So there you go. I hope this helps. I will post the full diagram. This is my circuit. I use an electrolytic capacitor on the VCC, and I use the ceramic capacitor on my RC filter. I do not know how I can improve this. I already checked my wiring a dozen times over, and there you go. I hope this serves you well. Thanks, Nick. I hope you're doing well.